Okay, so this is the last video lesson on section 1.7 exponents. So trying to yeah. So, right. So let's work on, we did, so Tuesday night, y'all did 1 through 12 and 13 through 23 odd. What I want to do is I want to work on some of the evens because those a lot of times can be just a little bit more complicated. But I want to start at number, let's see, let's look at number 14. So let's work at 14 until we run out of time. So go ahead and have this, whatever notebook you write your homework in. I want you to kind of start where you left off. I'll write the problems on the screen, but if you want to look at them right now, we're starting on page 41. And so we can work through these. I'm going to go ahead and work through these, but you guys do your best to keep up and let me know if you get the answer before I do. We did the odds, the odd numbered ones. We did 1 through 12 all, but now we're doing some of the even ones. So that's why I'm starting on number 14. And my pen decided to stop working.
Yeah, that homework, right now you have it because it was with my English.
Recording.
Okay, number 14, that's right, pen doesn't work. Why do you do? Why?
I have to say I didn't. I think it's because of drop.
Oh, that could be it, actually. I think you're absolutely right. Thank you, Timmy. Look, see, there's my scribbles. I had switched it for my algebra class and didn't realize it switched for everything. All right, so this is page 41 and 42. Section 1.7 homework questions. So we're going to do numbers 13 through 30 through 40. Why did I say 13? I'm sorry. 14 through 40 even. All right, we'll see how far we get. So number 14, we have the problem 7 to the power of 1. So what is the value of 7 to the power of 1? It's 7. That is a good example to have so that you know when it comes to exponents, you know, every number has an exponent of 1 when it's by itself. However, we don't bother to write, that's extra. There's no need to write that every time you write a number, but you need to recognize that you have 1 7. All right, number 16, we have 14 to the power of 2, or otherwise known as what? 14. Yes. What do we call anything to the power of 2? Squared. Thank you. So yeah. Whoa. Goodness. There you go. That does help. 14 times 14 is 196. Good job, Isaiah.
So with
You could do maths.
so to the power of 4, would it be tesseract?
Yeah, I don't know. The 4th dimension, maybe. All right, what about 2 to the power of 7? What is this? Is it 2 times 7? Right, 2 times 2 times 2 times 2 times 2 times 2. You don't have to write it out like this if you don't need to. 1, 2, 3, 4, 5, 6, 7. But when you get this many, yeah, you're gonna probably want to write them out so you don't forget one. It is 128. Yes, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Bring the next one. What? I know I'm really hungry. 32 times 2 is 64. And 64 times 2 is 128. You're remembering the exponents from last year? Yes. All right, so let's flip on over to page 42. He's got it. Number 25 to the power of 3. What do we call that? 5 cubed, otherwise known as 5 times 5 times 5. Yes. So 5 times 5 is 25, times 5 is 125. Think of it in terms of quarters. Once you got that 25 in there, how much money is 5 quarters? $1.25. Okay, 22 is 10 to the 4th. What do we do with powers of 10? Okay, yes. So I think what you just said is you take your exponent, and that's how many zeros are in your answer. So 1, 2, 3, 4, and then you throw that 1 in the front of it. 10 is the 1, right? 10 to the power of 1 is your 1 0. So you're really only adding 3 more after the 10, which is 10,000. That's where it does get tricky. You've got to kind of know that the 10 already is 10, 1, 10, 2, or you write it out, 4 tens. Right? How many zeros do you have? 1, 2, 3, 4. Yep. So you end up with 10,000. And 1 times itself 4 times is how much? Is what? 1. 1 times itself 1,000,000 times. It's still 1. Tomorrow? Exactly. It's still 1 times 1, and you're throwing all those zeros on the end. So the rule still works. All right. 1 times itself 1,000,000 times. That's what I said. 1 times it's 1 times 1 times 1 times 1 times 1 times 1 until you can say it 1,000,000 times. Still 1. You thought I was saying 1 times 10 million. I got you. All right, 24, 12 squared. You better have this memorized. This is part of your multiplication tables. 144. If you don't, work on those memorizing those multiplication tables. Yes, and until you catch that, you're right. So don't do 12 times 2. This is 12 times 12. 26. All right, in this case, we're finding each product and we're doing it multiplying numbers with exponents times other numbers. So 26, we have 3 times 2 to the power of 6. Order of operations, what do we do first? We solve the exponent first. So this becomes 3 times 2 times 2 is times 2 times 2 times 2 times 2, 64. So 3 times 64. And if you get to some of those bigger ones outside of our memorized multiplication tables, don't hesitate to start writing it off to the side. So this becomes, 192. So this is 64 times 3. You can write it vertically. And you get 192. All right, 28. So 28 is 9. Right. So here we have something very similar to scientific notation. This is just 9 times 10 to the 5th. So we have how many zeros? 5 zeros. And then 9 times 1 is 9. So then just check for your comma and you have 900,000. Number 30. 2, yeah, those glasses are making all the difference, aren't they? 2 times 4 to the 3rd. What do we do first? Yeah, I think so. So we do our exponent first, right? So we do 4, which is 4 times 4 times 4. is the 2 raised to the power of 3? We'll test that out. That's a good question because that's a very common attempt. So then 16 times 4 is 64. Let's go ahead and solve what we have. So this becomes 2 times 64, which is 128, right? 2 times 4 is 8, 2 times 6 is 12. So we had the question, what if we did 2 times 4 cubed? Well, what's 2 times 4? 2 times 4 is 8. So if we did that instead, I'm just going to do that over here, 2 times 4 cubed, then that means we would change that to 8 cubed. And I'm showing you why this is not right, but it's a good idea to work through. So this becomes 8 times 8 times 8. So what's 8 times 8? It's 64, which is starting to make us think we're on the right track, right? Because 64 is the same thing as 16 times 4. But now we're multiplying it times 8 instead of multiplying it times 2. So what's 64 times 8? 32, 3, 48 plus 3, 51, 512. So it's a lot more than that. So the only time that you would multiply, that's why order of operation is so important. That's why we do our exponent before we do our multiplication. So the only time that that would be the same, you would have to have parentheses around the 2 times 4. Because if you look at order of operations, parentheses come before exponents. So then you would solve 2 times 4, which is 8, and then you would raise it to the exponent of 3. So 8 times 8 times 8. We're still on 30. I was just walking 32. Oh, the last one is 40. We're going through 40. Okay, so let's go ahead and move on. 32. That really is a good question because a lot of people may try to go and solve the multiplication and then raise it to the exponent. And that's a common logical thought process, but you must have parentheses around the 2 times 4 before you can raise that to a power. Otherwise, it is just the number it's looking at, or just the number that the exponent is right next to. Okay, 32, 8 times 6, 8 times 10 to the 6th. So how many zeros do we have? Yep. And then we just, yep, 1, 2, 3, 4, 5, 6. And then 8 times 1 is 8. So 8 million is it. Good job. All right, 34. So what number to the power of 6 equals, this is different. Oh, right. Okay, so 34 and 36 say find the value needed to make each sentence true. Yeah, we've got 1 million. Well, we just did that with 32. So you guys see that the only way you could end up with a number that has 6 zeros and it's raised to the 6th power. You're silly. Yes, it is a 1 with the 0 at the end of it, which makes it a 10. Yes. All right, 36. 36 gives us 2 to what power equals 256. Do y'all know how you can work this out? Have you ever done
Yes, I
the
have.
prime factorization trees?
I know.
107. Or 100.
So 2 times itself 108 times gives us 256.
I think it's 128 plus 1.
It is, yes.
So it's
Let me show y'all this. This is what I would do. Now, in this case, you're supposed to just kind of know, work through it. 2 times 2 is 4, times 2 is 8, times 2. But let me show you something else. And surely y'all have seen this before. If not, we will learn this soon. So prime factoring tree, prime factorization. You start with 256, so we know 2 goes into it because it's even. So 2 goes into 2 how many times? 2 goes into 5 how many times? And then 2 goes into, carry our 1, 2 goes into 16. Exactly 8 times. So, yes.
But technically, so if 100, if I put on 2 to 100.
Okay. So let's continue to go down, and you're looking for prime numbers. So you need to get it until you have all prime numbers. So 128 is even. So we know 2 also goes into 128. So 2 doesn't go into 1, but 2 goes into 12 how many times? We're dividing. 2 goes into 12.
6 times.
6 times. I'll show you at the end. And again, y'all might not have seen this before, so I might be making it worse, but I think you have. So 2 goes into 12 evenly.
I've done
6
that
times.
before, but I don't remember how.
Okay. And then, so there's no remainder there. So 2 goes into 8 how many times? 4 times. Again, we have an even number, 2. Okay, I'm dividing. So I'm taking these 2 numbers at the bottom of these lines are the 2 numbers when you multiply them together, they equal the number at the top, right? So you have to divide to find those numbers because division is the opposite of multiplication. So I'm finding out what number times 2 equals 64. The easy way to find that is to divide 2 into 64. So 2 goes into 6 how many times? 3 times, no remainder. 2 goes into 4? 2 times. All right, so I have another 2, and 32 is not a prime number. We remember our prime numbers, right? Any number that is only divisible by 1 in itself. Okay, so 2 also goes into 32. So 2 goes into 3 how many times? 1 with a remainder of 1. So we carry that to the 2. So 2 goes into 12 how many times? 6 times. All right, 16 is also even. So we have 2 times what equals 16? 8. All right. 2 times what equals 8? And then 4 gives us our last 2's. So now we have all prime numbers. They just all happen to be 2. So your prime factorization here is 2 times 2 times 2. 1, 2, 3 times 2 times 2 times 2. Whew, goodness. One more, right? I have 1, 2, 3, 4, 5, 6, 7, and 8. So I have 8 2's. So, and all of those equal 256. Therefore, 2 to the power of what equals 256? 8. 2 times itself 8 times equals 256. No? Now, I started with the answer and went down and used prime factorization. Do any of y'all need this? I'm just going to erase it if you don't need it. Well, we'll wait. We haven't really gotten there yet, but you've kind of seen it before. That doesn't look like complete new, maybe to you. You've probably seen it. You would have gotten it in public school. The other way to do this, if you don't know how many times 2 times itself equals 256, well, you just start multiplying. 2 times 2 is 4. So that's 1 and 2 times 2. That's my third 2. That equals 8. Let me get down here. 8 times 2. This is my fourth 2 equals 16 times 2. Keep myself consistent here. This is my fifth one. That equals 32. 32 times 2 for the 6th time equals 64. All right. Okay. Yes. And then that times 2 for the 7th time equals 128. Really? Okay. And then 128 times 2 for the 8th time is 2 times 8 is 16. Carry my 1. 2 times 2 is 4 plus 1 is 5. And 2 times 1 is 2. Well, we just found it. So how many exponents do we have? 8.
It's kind of weird. Elementary school.
Okay. Let's move on to number 36. We're almost done here. Wait, I just did that, didn't I? I did do that. Sorry. We just spent so much time on that. Let's not do that again. All right, so for number 38, number 40, they're asking that you write the expanded form with exponents for each. So we did this a little bit with our skill checks yesterday. So let's look at 38. They're asking for 2,760. So the 2,000 in expanded form is represented by what? 2 times what? Gives me 2,000. 2 times 1,000. Remember, there's 2 steps to this. The 700, Zachary, is what? 7 times the 700. So now we're doing expanded form. Yep, 7 times 100. All right, and Timmy, the 6 is 6 times what? What place value is it in? So it's 6 times 10. Yeah, the next step is to move this into the exponent version. And then, of course, when you have a 0 in the one spot, it's 0 times 10 to the 0. All right, so now we put this in exponential form. This is 2 times 10 to the what power? Power of 3. How many zeros do you have? Zachary, are you writing these down? You need to have these in your notes. This looks like something they would love to put on a quiz. All right, so for the 700, this is 7 times 10 to the what power? How many zeros do you have? There you go. Plus 6 times 10 power of 1. And then, I'm sorry, I already did the other one in exponent. Because it's 0, it should be 0 times, let me fix this. This should be 0 times 1. And when you put that in exponential form, 10, anything to the power of 0 is 1. Yes. Okay. So this is the answer they're asking for. The expanded form with expanded form with exponents for each value of 10. All right, last one, number 40 is gigantic. Oh my goodness. I hope y'all got room left. I tell you what, I think we can go ahead and just write this in exponential form and be done with it. This is where it gets really, really necessary to do it in exponential form. All right, so 2 times 10 to the power of 6, because you have 1, 2, 3, 4, 5, 6 zeros. So that's 2 times 1,000,000, which has 6 zeros. Plus, all right, let me, Zachary, what about the 6? 6. 10, yep, 6 times 10 to the 5th, plus Timmy, the 7, plus 7 times 10 to the what? Right. Now you'll see, I know that looks very intimidating, but once you figure out, now double check your first exponent, make sure you're right, but once you figure out your first one, it goes down 1 exponent each place value you drop. So, well, just 1 line and then on to the next line. Just row and then row under it and then row under it. You got a little room underneath it. Yeah. Probably should just start it on the page. But you only had that one, didn't you? Right? Okay, so let's see, sorry, lost track of, we did the 7. So then we have 3. 3 times 10 to the third, because that's the thousands place, so you know you have a 0. All right, now, there is a 0 in the hundreds place. So we don't include that in our exponential form. All right, no. We would leave that. It's an understood 0 because 10 to the first plus 9, whoops, times 10 to the 0. And we honestly could have done that with number 38 as well. We could have just eliminated this whole portion here. Because you know, if there's no expanded form for it, that it's just 0. Okay. All right, well, that is it for today. Because we're gonna start section 1.8. But I'm not gonna do that until tomorrow.
Where